This video will teach you how to solve quadratic equations using the quadratic formula. So if we take a look at example 5 in our notes, if we want to just review and try to see if this can be solved by factoring, we'd have to make the equation equal to 0, so we would start by adding 20 to both sides. Okay, so then when we factor, we look to see if there's a GCF, which there is no GCF here. So then we would take our A and our C and multiply 3 times 20, which is 60. So we'd have to think of anything multiplies to 60 and adds to 17. So 1 times 60, 2 times 30, 4 times 15, 5 times 12, 6 times 10, and because it has to add to a positive, we know the bigger number's positive and the smaller number's positive to multiply to a positive. So 5 and 12 would work because they add to 17 and multiply to 60. So then the method that I taught in class was you take whatever this is, which is 3x, and we put it here and we put it here, which clearly that's wrong. That makes 9x squared. So we have to take care of that error in a second. So we're going to go ahead and insert the 5 and the 12. And now let's take care of the fact that this makes 9x squared. So we look at the pair of numbers together and see if there's anything that divides both of these. So since there is not, it would stay 3x plus 5. But over here, both of these 3 can go into, so we would get x plus 4 here. So now before we continue, let's make sure that this makes sense. 3x times x would make what we started with, and 5 times 4 would get you the 20. If you want to check if it does really work, you'd have to FOIL it all out. So then we would take each factor and set it equal to 0. And we would get x equals negative 5/3. And then over here, we would get x equals negative 4. So that is how we would solve it by factoring. And of course, if we want to check this answer, I'm going to just model one of them. So I'm going to take negative 4, and I go back to the original problem, and it says 3 times, and we got negative 4, so we need to use parentheses when we have a negative and an exponent, plus 17 times negative 4. And when I click equals, if my answer is correct, we should get negative 20. So then I know it's correct. And then we could check this one if we want to be sure, but for time's sake, I'm only showing one. So now the quadratic formula, so again, on a test or on homework, I don't care what method you use, so that would be factoring. Now the quadratic formula would require you to memorize this formula here, and it says to find x, you would need to take negative b, so it would have to equal 0. So when it equals 0, that's how we know what a, b, and c are. So it would be negative b plus or minus b squared minus 4ac, all of that divided by 2a. So we would get negative 17 plus or minus 17 squared, 289, and then negative 4 times 3 times 20 is negative 240, all divided by 6, and then negative 17 plus or minus, so we would combine that with 289, and we would get 49. And then when we get it down to when there's 3 numbers, we always start with the radical. We simplify the radical first, the square root of 49. So the square root of 49 is 7, because 7 times 7 is 49. So the radical's gone. So we'd have negative 17 plus or minus 7 all divided by 6. So now to get our two answers, we would do negative 17 plus 7 all divided by 6, and we would get negative 17 minus 7 all divided by 6. So negative 17 plus 7, that's negative 10 over 6 here. And then we would simplify that. 2 goes into both of these. So we'd get negative 5/3. And that's exactly what we got over here. And then negative 17 minus 7 is negative 24. Divided by 6 is negative 4. And that's exactly what we got over here. Okay, so let's go ahead and try one last one here. Let's go ahead and use the quadratic formula here. So we'd have, to get x, negative b, so this would be a, this would be b, and this would be c, so it'd be negative b plus or minus b squared minus 4ac, all of that divided by 2a. So then this would say the opposite of negative 24, so that would change to a 24. And then negative 24 squared, so negative 24 squared is 576. And then negative 4 times 6 times 25, that would make negative 600. All of that divided by 12. And then we'd have 24 plus or minus, so we'd have 576 minus 600. That would be negative 24. All over 12. So now at this point, when we have our three numbers, we always start with the radical and we simplify it just like we learned last chapter. So if I have the square root of negative 24, I would separate it to square root of 24 times square root of negative 1 so that I can simplify the square root of 24. This would become, we would substitute in I. And the square root of 24, if we use our list, we know that 4 goes into 24. So we can write it as square root of 4 times square root of 6, which is 2 rad 6. And again, all of this is being multiplied here, all of this. So because all of this is getting multiplied, the order of this doesn't matter. So I prefer to put the I in the front here, so that way it doesn't get confused as getting stuck inside that radical. So now I would have 24 plus or minus 2i rad 6, so I would get rid of this and put what we got there, the simplified version. And then once the radical is simplified, that is when I look and see, can anything go into 2, 24, and 12? So 2 can go into all three. So we would get 12 plus or minus, 2 divided by 2 is 1i, so I just put 1i. And then 12 divided by 2 is 6. And then this would be our final answer. So I know that 6 can go into 12 and 6, but remember, if we want to leave it as one whole answer, then we wouldn't divide these two because it doesn't go into this one. So it would not be wrong if you did. So in other words, if you did 12 divided by 6 and you split it up like this, this is fine. And that's the only way you can make this a 2. But then you would have two fractions to have to, or two separate terms. So this would be okay, or this answer here.